Alright. Hey guys, it's Mari from WTFSKY, and here's part 3 of Complexity. Back to the small, where we begin our climb up the ladder of structure. There are 2 kinds of quarks that are found in normal matter. Physicists call them flavors of quarks. These quarks are the up quark and the down quark. A proton's formed from 2 up quarks and 1 down quark, while its slightly heavier cousin, the neutron, is formed from 2 down quarks and 1 up quark. The red, the green, the blue colors of the quarks represent a property that attracts them to one another. It is this color charge property of the quarks that hold them together in a proton or neutron. These protons and neutrons can then combine in the form of a nucleus of each element in the periodic table. 1 proton in the nucleus makes hydrogen. Two form helium. 6 carbon. 8 oxygen. 79 is gold. And 92 is uranium. Neutrons help hold the protons together. Because of their electric charge, protons would repel each other more strongly if neutrons were not present, and the heavier elements would come apart. There are approximately as many neutrons in each element as there are protons. Atoms are formed when the positively charged protons in the nucleus capture the negative electrons. Neutral atoms have captured 1 negative electron for each positive proton in the nucleus. So, hydrogen has 1 electron to go with its 1 proton. Helium, 2 electrons. We have carbon, has 6. Onwards to oxygen, has 8. Gold has 79. And uranium has 92. There are nearly 90 stable elements. The largest of them can contain close to 800 fundamental particles joined in a complex but stable structure. But electrons cannot just gather around in a crowd. Once again, the strange, wonderful world of the tiny has some idiosyncrasies. Electrons arrange themselves in shells inside an atom, like layers of an onion, and only 2 electrons can fit per layer. So the more electrons an atom has, the further away from the nucleus the outer shells must be, and that means these electrons are loosely held. It is this difference, how tightly electrons are held in each different kind of atom, that determines the chemical properties of that element. This accounts for the ability of metals to conduct electricity, the aloofness of noble gases, and the formation of molecules. It turns out that protons in 2 or more different nuclei can sometimes capture and fight over the same electron. And when that happens, atoms of different elements are joined together to form molecules. This oxygen molecule is sharing 2 of its electrons with 2 hydrogen atoms. This is how a water molecule is formed. Some molecules can be quite large and complicated. Carbon, hydrogen, and oxygen join together to form some of the most important large molecules. Amino acids are molecules that are necessary for carbon-based life, and recently it was discovered that amino acids form naturally and spontaneously in the vast gas clouds of outer space. Since these molecules are precursors of life, it's important to know how abundant and universal they have turned out to be. Somewhere about here, our measurement of simplicity starts to edge towards the complex. At the level of complex molecules, existence is pretty reliable. Molecules such as adenine are too large and heavy for the uncertainty principle to enter into their description, and quantum mechanical oddities are rarely encountered at this level. But adenine molecule is still identical with and interchangeable with every other. There isn't sufficient complexity to generate uniqueness. And a movie of even a complex molecule forming looks equally plausible running both forward and backwards. So reversibility still indicates simplicity.
That molecule forming looks pretty different to me than when it's breaking apart.
I agree. It looks natural breaking apart, but pretty forced when running backwards. You are right, and that is an indication that we are crossing the line from simplicity to complexity. Jeeves, again please.
Thank you for tuning in to WTFSKY. This is going to be continued onward and outwards over to Section 4 of complexity. As complex as it is. It's not as crazy as Nibiru or exciting. I know, but it's complex, and it's interesting, and it's real, and it's cool. So talk to you later, guys. Have a fabulous day. Again, tune into WTFSKY on YouTube. We got a Facebook group. I'm not very active because I'm lazy. And what else do we got? Got WTFSKY.com. Amen. Have a great day. Goodbye.